Hey, you guys, it is me, Miss Noise. So our lesson for the week is going to be a continuation of for spring break, where we're talking about linear functions and basically how to find a rate of change. So as we would do any other time in the building, we're going to start with a little warm up just to get our brains working, just to get a refresher on what Miss North actually wants from us. So let's look at our do now. Our do now says to complete the table and then give the unit rate. So you were giving a distance over gas used. So the distance I drove over the gas I used. So if I drove 100 miles, I only used 5 gallons. So I want you to find out how many gallons would you use if you only drove 200 miles. How many miles would you have driven if you used 15, and so on and so forth. And remember, we're looking for the pattern in this. So go ahead and take a minute and figure those out. All right. So we have now completed the table. So after you completed the table, you would have found out that I would have had to multiply 5 by 20 to get 100. And the way I would have figured that out is by dividing. 5 goes into 100 20 times. So 5 times 20 gives me 100. And I'm going to use those inversely. Remember that word inversely means opposite. So if I'm going from the top to the bottom, I'm going to divide. If I'm going from the bottom to the top, I'm going to multiply. So this way. So I have 200 and I want to find out how many gallons did I get. So again, we're inversing. 200 divided by 20 gave me 10. So if I drove 200 miles, I only used 10 gallons of gas. And then doing the opposite, if I only used 15 gallons of gas, what did I do? I had to multiply by 20 to get to 300. Now with this one, we see that it already gave us to it, but I want to go ahead and check to make sure that our rate of change is constant. And so basically, how do I get from 40 to 20? I'm going to divide by 20. So then therefore, I'm going to keep the same pattern. And what I want to do is I want to see what was my pattern from here to here to here to here to here to make sure that I know how to get here. So I can see that 100 plus another 100 is 200, plus another 100 is 300, plus another 100 is 400. So I'm going to do the exact same thing. I want to add 100 because, again, my pattern has to be constant. So down here, I'm seeing, well, what did I increase by? I increased by 5s. 5, 10, 15, 20. So that means I literally had 25. And then I want to go back and check that. So yes, 25 times 20 gives me 500. And so on and so forth. So let's get into what we're going to be talking about today. So basically the goal for today is, can I determine the rate of change from different linear representations? So I can compare linear functions presented at the same time of different forms. So basically what I want you to be able to do by the end of the week is determine the rate of change from different linear representations. I want us to pause and reflect on what are those different linear representations. Remember, that is a graph. That's a table. If I gave you an equation, or if I gave you a word problem, which is a verbal descriptor, can I find the rate of change from all those things so that I can compare? So let's pick out some mid things. So when it says I'm going to determine, I just want you to figure it out. Can I figure out the rate of change? Remember, your rate of change is your M. So can I figure out the M from different representations? So then I want to be able to compare. When I mean compare, Ms. North means how am I telling they are the same and how are they different? Properties of linear functions presented in the same in different forms. And that's how we said a table, a graph, verbal descriptor, and equation. So let's get into this. So basically, Ms. North is going to flip back and forth to, again, from what you're seeing from what she's seeing, so that you can see what we're going on. So, for representations, if I'm looking at slope, I'm going to go pick 2 points off this line. So I have 0, 60, and I have 120 and 75. And so basically, Ms. North is going to switch back so you can see exactly what she did. 0 and 60, 120, and 72. I'm sorry, I said 75 earlier. So let's go down here so we can see. So the same way we would have done before, you're going to take your notebook paper and you are going to write X and Y, draw my T table, 60, 0 and 60, 120, and 75. What plus 0 gives me 120? 120 plus 0 gives me 120. What plus 60 will give me 72? What plus 60 gives me 72? 12 plus 60 gives me 72. And the way that I can check that is just doing the exact opposite. 72 minus 60 gave me 12. 2 minus 0 is 2. 1 minus 6 is 1. So then, remember my m is the difference of y over the difference of x, right? So my difference of y was 12. My difference of x was 120. And I'm now going to divide. And I'm sorry, Ms. North left her calculator. But, again, 12 divided by 120 is 0.1. So we're going to switch back to our slideshow to see if that matches. And it does. That's exactly what we did. So let's look at the next one. The next one said, I was given a graph of miles and cost for crosstown mowers. I was given an X and a Y. And so I'm looking at my T-table of X and Y. I have 10 and 35, so I'm going to put that over here. And I have 30 and 45, 30 and 45. What plus 10 will give me 30? 20. 20 plus 10 will give me 30, so then therefore that's the difference of X. What plus 35 will give me 45? 10. 10 plus 35 gives me 45, so I'm going to put that on top. So then, of course, like I said, the difference of Y is on top. The difference of X is on the bottom. So then 10 over 20 gives me 1/2, which is 0.5. Going back through it, well, how would I find that through a table if it only gave me the table? So let's see here. Ms. Numbers actually just going to replicate because you're writing your notes. So these are your notes. So your notes. Your table is 3, 6, 9, 170, 140, 110. So what plus 3 gives me 6? That is 3. What plus 170 gives me 140? Let's stop here. So basically, if I had a bigger number and I went to a smaller number, I'm no longer adding. I am now subtracting. So what minus 170 gives me 140? And that was 30. So then m equals negative 30 over 3. Negative 3 goes into negative 30, negative 10 times. Therefore, your m equals 10, negative 10. And then again, I want you to make sure that you're stopping this video every couple of minutes and copying down example 1 and example 2 because you are going to need them for your assignment. So the student council is selling t-shirts during Spirit Week. It costs $20 for the design and $5 to print each shirt. Remember, we're looking for very specific vocabulary when we're looking for which one is the M and which one is the B. Would I pay $20 extra for every shirt just to design it? If we all have the same shirt, if we all had the same Woodland t-shirt, do we all have to pay for that same design? No. We're going to pay for one design and multiple t-shirts with the same design on it. So then therefore, would the 20s be the M or would the 5 be the M? And then we're going to look at what this word each means. $5 each shirt. That's your M. So each one is how much you charge per rate. So then therefore is your rate of change. Lakeside Marina charges $35 rental fee for a boat in addition to charging 13 hours an hour. You have to look at, well, for 35, will I pay a $35 rental fee for every hour or would I pay it every time I rent the boat? On top of that, if I'm paying $15 an hour, would I only pay that for one time, even if I got 4 hours? No, I'm going to pay that each hour. And that each goes back to that word per. And that's your rate of change. So 15 would be your M. So, So, comparing your rate of change. When I'm comparing a rate of change, I am literally checking for 2 things. So, the first thing I'm checking for is either which one is larger or which one is smaller. And we know how to do that. Which number or for which situation would one be bigger or would one be smaller? So, when I'm comparing a rate of change, I want to make sure that I put it back in the same representation. So, if I'm comparing an equation, I want both of them to be equations. I don't need one of them to be an equation and one of them to be a graph. They both need to be equations. So let's look at this one. I'm looking for the m, which is the number attached to the x. One more time. The m is the number attached to the x. So for equation 1, I have y equals 3x plus 4. Well, what number is attached to the x? The 3. For equation 2, I have y equals negative 3 minus 3. Negative 3x minus 3. Well, what number is attached to the x? The negative 3. So then let's look at those two numbers attached to the x. I have a positive 3 and I have a negative 3. So at the end of the day, which one is more? That positive number is always going to trump that negative number. So positive 3 is larger than negative 3, then therefore equation 1, rate of change is larger. Now let's look and see if I'm looking at graphs. If I'm looking at the graphs, I have a graph here with a red line, a green line, and I brought blue, but it looks kind of purple now, but blue line. When comparing the slopes, I'm looking for the one that has the steepest. So look at it as if you're looking at climbing a mountain. Would I want to climb a mountain with the highest steep or the lowest steepest? I'm usually probably going to go for the lowest one. So the lower one is the easier one. You always want to walk like a flat surface. So basically, the higher that steepness is, or the harder it's going to be to climb that mountain, the higher the rate of change is going to be. The lower that it is, such as the blue line, is the lowest steepness, meaning that it's the lower rate of change. So let's compare this. A zebra's main predator is a lion. Lions can run to a speed of 53 miles per second over short distances. The graph at the right shows the speed of the zebra. Compare the speed. So I'm comparing the speeds of a lion, which a lion can travel at a rate of 53 feet per second, and I'm comparing that to the zebra, which is at 1 second I'm running 59 feet. At 2 seconds I'm running 118 feet, and so on and so forth. I'm looking at these little boxes that they gave me. So then basically I saw that, well, the zebra, if it's at 1, is 59. 59 over 1. Clearly the zebra runs faster because the rate of change was 59. So I'm going to come up out of here. So then let's go back. So looking at my two comparisons, I have a lion and I have a zebra, right? And so my lion runs 53 per second. So that 53 is my m. So then therefore y equals 53x. Leave that there, right? So then now I have my points, 1 and 59, and I have 2 and 118. So now I'm going to make my table, x and y, 1 and 59, 2 and 118. What plus 1 gives me 2? 1. What plus 59 gives me 118? So again, not a mental math thing. Ms. North is going to put it in and subtract. 118 minus 59. Take away my 1. That's 9. 10 minus 5 is 59. So 59 plus 59 gives me 118. So remember, my m is 59 over 1. Right? Can you see that? Which I can simplify to regularly just 59 because anything over 1 is that number. So now let's do that. If I have m is 59, that means y equals 59x. So the lion was y equals 53x. The zebra was y equals 59x. Well, which one is bigger? To compare them, all I'm doing is that. Comparing. This one's bigger. This one is smaller. Easy peasy.